Now we'll discuss intensity at the point of interference. As we know, for a given wave, intensity is directly proportional to square of its amplitude. Or we can write I is equals to Ka square for a given medium, and for a given wave all other factors are constant. So as the amplitude of a given frequency wave changes, its intensity depends on its square. Now we can say when two coherent waves interfere, the resulting amplitude is given as we have just now studied, the value of R is given as square root of A1 square plus A2 square plus 2A1 A2 cos phi. So R is the amplitude of the modified oscillation at a point where the two waves are interfering. So here we can state the intensity at the point of interference is this intensity, which can be written as a resultant intensity, is Kr square. Now if resulting intensity is Kr square, on substituting the values we'll get this resulting intensity, which can be termed as Ir. It is Ka1 square plus Ka2 square plus 2Ka1 A2 cos phi. Just have substituted the value of R over here. Here we can see this Ka1 square, we can term it the intensity of the first wave, Ka2 square is the intensity of second wave. And the second term Ka1 A2 can also be written as root of Ka1 square multiplied by Ka2 square. So this can be termed as root of I1 I2. So in this situation, the resulting intensity at the point of interference can be written as I1 plus I2 plus 2 root of I1 I2 cos phi. Now this is the expression which we use for resulting intensity at the point of interference. So we can see the intensity of waves after interference at the point will be modified and will depend on the individual intensity as well as the phase difference between the waves. Let's also analyze the various situations, how this intensity varies with intensity and phase difference. As just now we have seen that resulting intensity at the point of interference is given by this expression. In some situations, say if the waves are of equal intensity, I1 equals to I2 is equals to I0, then the resulting intensity will get 2I0 plus 2I0 cos phi, and which can be written as 2I0 1 plus cos phi, which can be opened by using half angle expression of cos phi, where we know 1 plus cos phi can be written as 2 cos square phi by 2. On substituting, we'll get the resulting intensity is equals to 4I0 cos square phi by 2. This is also a useful expression for the intensity at the point of interference of two waves of equal intensity I0 having phase difference phi. This can be further analyzed like for constructive interference. We know that the phase difference can be given as 2n pi. If we substitute here 2n pi, this cos square phi by 2 in this situation will become cos square n pi, which is always 1. So we can write the maximum intensity at the point of interference is 4I0. This is the maximum intensity at the point of interference. Similarly, we can talk if the wave intensities are not equal, cos phi can also be written as 1. So in this situation, if the intensities are unequal, maximum intensity can be given as I1 plus I2 plus 2 root of I1 I2, as again cos 2 and pi will also be 1. So in this situation, this expression can be written as root I1 plus root I2 whole square. This is the expression for maximum intensity if the waves are of unequal intensity, and if waves are of equal intensity at the point of constructive interference, the maximum intensity will be 4I0. Similarly, we can talk about destructive interference also. So we can write here for destructive interference, we know that the phase difference between the waves can be given as 2n plus 1 multiple of pi, or we can state that if waves are in opposite phase, these waves interfere destructively. So in this situation, if we calculate the value of cos phi, this will be minus 1. So if waves are of unequal intensity, we can write minimum intensity will be given as I1 plus I2 minus 2 root I1 I2. So in this situation, the minimum intensity can be given as root I1 minus root I2 whole square. This is the minimum intensity where the waves interfere in opposite phase. Now obviously if I1 is equals to I2 is equals to I0, obviously if the two wave intensities are equal, the minimum intensity at the point of destructive interference will be 0. If we are talking about sound waves, it will be complete silence, and if we are talking about light waves, we'll separately discuss in the section of light. It signifies complete darkness if we are talking about interference of light waves. Using the similar expression, we can also find one important term that is quite useful in various analysis, which is ratio of maximum to minimum intensities in the region of interference. As we already studied Imax and Imin, so we can simply find out the ratio of maximum to minimum intensities for two waves of unequal intensities. This will give us root I1 plus root I2 over root I1 minus root I2 whole square. If we substitute the values of I1 and I2, which are I1 is K A1 square and I2 is K A2 square. If we substitute the values, this will give us A1 plus A2 upon A1 minus A2 whole square. This is also a very useful expression for various applications. Just keep it also in your mind.